So we are now approaching the last session for today in this room. We're going to have a panel discussion on the topic challenges and opportunities in thermal management of electric and hybrid machines. And it's headed by Dr. Barry Flannery, we have seen before. And on his side, he has Dr. Lena Beckman from Webesto. We have Juha Leskinen from Ponsse and Florian Wieszolek from Rheinmetall. And then we also have a fifth one, who is not announced here, is Mr. Peter Höfner, Head of Sales Traction at Benning Elektrotechnik and Elektronik.
It's more exciting.
So that's our secret guest, so to speak. Please go ahead.
Great. So thank you all. I think everybody has been introduced, apart from maybe our final panelist here. Maybe might give an introduction just to yourself. I think everyone else has had a presentation today, so maybe just a 60-second introduction who you are.
6 seconds only, yeah.
Yeah.
Okay. So my name is Peter Höfner. I'm head of the sales department for traction-related product within Benning. We are involved in charging stations. We are producer of charging systems for multiple applications. Yeah, and I'm happy to be here to maybe speak about electrical infrastructure, which is a big challenge as well. So we've heard how to use energy efficient out of batteries, but we have to think about how to get back the energy from the grid into the batteries. And that is my task at Benning.
Great. So what I might suggest is that, out of fairness to Lena, she's here on the battery side, so you can be the battery pack supplier. Juho, you can be the OEM. Florian, you're the thermal system supplier, and you've just introduced yourself there, and I'll remain impartial. So I suppose to start off the discussion, we just heard from Kreisel and a few others. I suppose one of the general questions of why do you need thermal management in a battery? And maybe just amongst the panelists, I'll ask maybe 2 or 3 questions and then open it up to the audience and everybody else to look at it. So maybe just to start from the end user, Juho, I mean, from your app, what does thermal management mean to you, you know, on the vehicle side?
Okay, thank you for the question. I think from the machine side that we make, I think the thermal management, or the main requirement is to have the battery at the optimal temperature all the time when we need it, or when the machine user needs it. So I think that's the main requirement. And of course, we have to think about the machine level. So when we introduce a system that needs cooling or heating, it needs to integrate also into the rest of the machine. For example, for the cabin air conditioning and the complete solution. So we need to take into consideration the whole machine level. But mainly we need the thermal management for the cabin and for the battery to keep it in the optimal temperature.
I might just ask you, Florian, in terms of obviously one of the challenges in the off-highway segment is that many of the OEMs may not have that technical capability around, you know, active thermal management, integrating these much more complex systems. It's one thing to put a radiator on a diesel engine and have it switch on at 90 degrees C, something entirely different to have a heat pump in that system. So maybe you could give some insight of the challenges that the OEM will face as they now suddenly have to cool a low temperature circuit on top of everything else with potentially cabin air conditioning. Maybe a perspective from your side as the component supplier.
Yes, I think you already mentioned the different tasks inside the vehicle, and he gives us a task and we try to solve this task. So that's a little bit the both sides, and sometimes you get only, as I've shown, an Excel list of hotspots. Sometimes the OEM or the system integrator has already built up, engineered a sketch, an idea how to cool down or to heat up, but mostly cool down. And then I think it's very fast to the task. Oh, which components we can bring into this sketch, and the next step from the sketch is a 3D model, then the prototype, and then build up and testing. And then our task starts, and we have to engineer this. And as I mentioned at the beginning, it's very, very different. Sometimes the needs are very clear described. Sometimes it's only an idea of a cooling, and that's the challenging. And as I've shown in my picture, it's the beginning. This is a little bit exaggerated of the ice world, and then jumping to the battery cooling, or to the battery vehicle thermal systems. Yes, it's very different for each vehicle, also technical-wise, not only engineering-wise.
I suppose maybe for you, Lena, how would you advise Juho? He wants to go battery electric. He's just told you have to work at -40, +40. You've obviously Webasto has thermal products as well, but specifically on the battery side. And say for sake of argument, you're integrating with a Rheinmetall solution. I mean, how do you advise the customer on thermal, you know?
Yeah, so since I'm not the expert in thermal, but maybe on the battery side and system-wise, I made the joke during my presentation that the battery is like the human and they like it in stable conditions, 20 degrees Celsius to get the best out of it. So I would advise, of course, to use the thermal management system, and the answer to a lot of questions here is it depends. It really depends on the conditions where the system would be used. It depends on the size, on the number of batteries, on the power consumption, and so on. So advice would be really to see the load profile, for example, to do a simulation in the beginning and to design the system in the best way for the best conditions which apply to the special application. So here you can see yeah, we want to be a partner here and to support as well, that we have a real partnership, get the best information to get the best system for the customer out. So good data in, and then we will get a good system out.
Maybe to ask you a difficult question, because nobody was kind enough to ask you a question at the end of your presentation. Our colleague here, you know, is there a type of thermal management that's better than the other on the battery context?
Yeah, I have to say, of course, ours is the best. So otherwise, I wouldn't be a good salesperson here. But here as well, I would say it really depends. So even I showed in the presentation, we have different styles. We have a plug and play solution, but this maybe is not the best version for all kinds of applications. So we as well can offer a full-blown solution where everything is integrated. We heard already the cabin should be heated or cooled. Then we have maybe other topics inside the vehicle. Then the full-blown solution would be great, but maybe there's something in the middle as well. So as well here to be politically correct. So again, it depends really on the situation.
And then maybe a final one on the infrastructure and the charging side. Would you have any comment on the thermal management side specific to charging and the infrastructure of the vehicle? We do see some interesting concepts of potentially, at least I've seen them, off-board cooling systems, particularly for very high, very large scale systems. If someone's looking to do a DC fast charge of a 200 or 300 kilowatt hour pack, that's going to be a massive thermal load that is not going to be achieved with an onboard. The same way we have onboard chargers, we'll have onboard thermal systems. You know, do you have any comments on that around infrastructure, maybe tying in with charging solutions?
So I don't believe that the charger is the limiting factor in terms of ambient temperatures. But for sure, you have to operate your charger in certain conditions. The biggest issue is the plug. So when we're talking about CCS2, the standard common plug in electrification, we are limited to 200 amps when it is not liquid cooled. When you start liquid cooling in plugs, it can transmit much more, but then you need additional cooling, liquids, all that stuff, and it has to be, or it is maintenance needed then. And there's the question, is it needed to charge with such a high power, or do you have other possibilities for kind of decentralize your applications, etc., or swapping batteries? That's it. So that it depends on the application. Huh?
Depends. I think that's the answer to everyone. I'll open it up to the floor. Or you go ahead. Yeah, go ahead, Florian.
Yes, because it's fast charging, that's what the refrigerant system really likes, because this is the worst case. The car is standing, it's idle conditions, and you know from your car, if you're ambient conditions like today in Berlin, 30 degrees, and you drive to a red traffic light, then you really can feel how the cooling temperature rise up, perhaps from 5 degrees to 10 degrees. And now this is the case for the fast charging. You like to have the most cooling performance. On one hand, the waste heat during the cooling process, you cannot avoid. And then because it's a fast charging, the idea is that everybody still sits inside the car. Then this means you need also 7 to 8 kilowatt inside the car. That means the whole refrigerant system is blown up for this charging 20 minutes. And to be honest, it's a nightmare. And because the rest of the day you don't need this. And then to drive with a 20% system, it's not really efficient. So that's something from thermal system size I would like to avoid. So if this can be off-board, that means inside the charging systems, and there's something added as a plug-in, it would be interesting.
And maybe to add to that point, I think a lot of what's been talked about today for off-highway are big batteries, you know, hundreds of kilowatt hours, more than 100 for sure, 200, 300. Would you have a perspective on that? That, again, like what I was saying, I don't believe that can be dealt with an onboard solution, not easily anyway, unless you have 7 onboard cooling systems to deal with this, especially in a fast charge event.
Yes, thank you for bringing me back to the off-road industry, because I was still in the automotive industry. Yes, if you're in the excavator, I think then the cabin cooling is not so dominant than the cooling of the battery. But still, then you need somehow to bring the heat outside. The last meter is important,
yes.
And if the coolant is below ambient temperature, then you cannot cool down. So you need the refrigerant cycle in between, and then everything I mentioned 5 minutes ago is still valid.
Anyone on the floor? I'll go here first. Oh, maybe this gentleman first. He bet you.
Right. Thank you, the panelists. I have a general question looking for anybody comment on. Is pouch cell configuration a right configuration for off-road?
So we are not working with it at the moment. So as I said, we started with prismatic cells and coming now to the round cells as well, as a lot of other described today. So maybe as well to get the opportunities we have in the larger OE business, so to take advantage of that and to have better sourcing opportunities. So at the moment we are not evaluating these topics, so but maybe
I could add a general point on cell format. There's pouch, prismatic, cylindrical, of course. It depends on who you are. If you're Deere, a lot of the supply chain issues are not the same for you as they are for many other companies in the world. But having said that, even still at your scale, you do pale in comparison to automotive. So that's where we would still, from a Zero-Tech perspective, be pushing people towards cylindrical. Every supplier, cell supplier in the world wants to offer cylindrical if they want to get into automotive. So that makes it an advantage there. There is, I wouldn't say political reasons, but strong corporate reasons for pouch cells, particularly in Europe. There's a reason there's a 35 amp hour pouch cell, is because now that OEM is locked in to that format, and if they can't buy that, they have to redesign their entire platform. Whereas 2170 is 2170, so it doesn't matter who you buy it from. There are similar issues with prismatic. There are VDA sizes and things like that, but generally speaking, the availability is lower. You are somewhat locked in. So that is a consideration you need to make potentially on the cell choice that you make. And then there are technical considerations. Having big units of energy versus small units of energy creates its own challenges, thermal management, propagation, many other things. So it depends.
All right, maybe could I ask one more question to the panelists? If the cell chemistry goes to solid state, what do you see as the more management challenges or benefits?
Do you want to take that, or? I can give a quick perspective on solid state. It seems to be a little bit like nuclear fusion at the moment, that it's continually shifting out. I would argue that I know the nearest estimates are 2028, but you've got to remember that when that solid state comes online, it's going to be competing against Gen 3 plus Gen 4 lithium ion on the scale of hundreds of billions of cells per month of production capacity. So our perspective on solid state is that it's not going to eradicate all lithium ion chemistries today. It's going to be used in the applications where it's needed. It's going to be used in aerospace. It's going to be used in defense. It's going to be 2 or 3 times the cost of current generation lithium ion. So it will have a role, but I don't think there are a lot of logic to don't do anything at all in the battery world and then wait for a magical solution from solid state, because I think you'll be disappointed. And in terms of thermal management, it has different characteristics, of course. It may still need it. It does depend. Solid state, like lithium ion, is a family. There's many different solutions out there and how it works. So that will also need, in some cases, different types of thermal management. It's easier than current lithium ion, but it still may need it.
Thank you very much.
Maybe Florian, do you want to comment on that as well?
One small comment. I mentioned also, or spoke a little bit about heat pumps, and they need somehow a heat source. So and if now perhaps the battery pack go to solid state, and the waste heat becomes smaller and smaller, then the source for the heat pump can be reduced tremendously, and then you have to go to the ambient air as a heat source. You have always, but the problem is the lower the temperature, the less heat you can get out of this, but the need is very high. So the battery and the waste heat from the battery, perhaps with coolant temperatures 10-20 degrees, is a very agreeable in terms of technical solution heat source for the heat pump. And this could be an impact in the long time scale.
Maybe one general final point I'd make, and I might speak for you as well, Lena, that we like to also believe we have the best thermal solution in the world, but I hate thermal management. I wish we didn't have to do it. I think I speak for all batteries pack suppliers. Nobody likes thermal management. It's a pain. It's a pain in the pack design, and then once you go to the vehicle issue, thankfully we can push it on to Juho at that point. It's also an even bigger pain. So if we could have a system that required no thermal management, we would all do that in a heartbeat, but we're not banking on solid state right now.
What should I say now?
Maybe I can add something on that. I like that word pain because I'm wondering about the title of this discussion, Challenges and Opportunities in Thermal Management. It's only problem, I think. We are a company building electric tractors, and the whole cooling system is only a problem. I do not see any challenge. Yeah, I see challenge to solve the problems, but I don't see opportunities. I'm thinking since 10 years about what can I do with all that heat I'm generating. I do not know what. I just can get rid of it. But it is also about efficiency. It is inefficiency what we are fighting. So please make more efficient cells, more efficient motors, more efficient frequency drives. Then I have a smaller cooling system. And maybe we have to discuss that. So what is progressing, for example, in cells? Is this generation cells, is that more efficient when it is about heat than 5 years ago? Or is it just the same? Or is it improving? Or?
Well, yeah, it's improving, obviously. Internal resistance will be one of the main sources of heat. You also have electrochemical heat generation as well. And that's, those of you that follow Tesla, that's one of the main innovations behind the 4680, the larger cell format, and tabless electrodes. It's not really tabless, there's just millions of tabs in that context. So that reduces heat generation within the cells. But you will always have an amount of heat there in terms of fast charge and fast discharge. And I would agree with you that there are no opportunities. It's just minimizing the pain when it comes to thermal management.
And on the other hand, what is our experience that it is handleable. You can work with batteries and you can cool them and they just work. So the problem is not the biggest problem in the world, maybe.
That's definitely for you, Florian first, and then Pons, Juho, both. Well, maybe start with you, Juho, first, and then Florian. You might need to help him.
Yeah, I have to agree that it hurts every time we speak about thermal management in any kind of case. So it's complicated. But as an opportunity, if there is one, I would say that when we're working in cold environment and we have excess heat from the battery, we can use that to warm up the cabin. But that's about it from the opportunity side. So everything else is a bit of a pain in there. But we, in terms of integrating the battery cooling or heating system to the machine, I think it's really important that it will become like a part of the whole system. So I don't like it to be a separate system, but fully integrated to the whole machine thermal management system. So we can, if the case arises, we can use the excess heat, for example, for other purposes. But that's about it.
Yes, I'm hesitating a little bit about this to answer or how to answer, because on one hand, I like this integrated solutions on one hand, but on the other hand, you're already looking, yes, getting complicated and complicated. And sometimes it's better you use for certain solutions electrical heater. It's easier, it's not the best efficiency, but it's easier to implement and totally makes more sense. So this question is valid, but the answer, as I mentioned in my third page, each system is different, and you have to look really in what makes the most sense. And if it's an engineering for only 10 vehicles, does it make sense to spend 3 engineering years on this, or to make it quick and dirty, and then it's done? So it depends really. I cannot.
Maybe one piece I'd add to that, of course, we only try and supply the pack. We do get asked for everything else as well. But we find for most customers, they just want a box. You know, the battery is a box. What's thermal management? Can it come in a box? And where can I put it? Yeah, well, that's the Webasto product and even the Rheinmetall product. Like, that's the way we see it. It's that for a lot of these applications, for these markets, there maybe lower sophistication or just less expertise there. Maybe look less at what you see in automotive, which is extraordinarily complex, how it's routed and it's built all around the vehicle. For most of these things, it's a box on a frame rail or on the vehicle somewhere. Seems to be where we see at least most customers wanting to try and find a solution. I'd say that's ideally what you want as well. Yeah.
And the other part of the answer is, I think it is given by you, Barry, this morning, because you said to us, everything above 25 degrees will eat your lifetime. And all these other components can run up to 65 degrees, so that is no problem at all. So please separate these coolings, I think.
Yep.
Yeah.
Sure. Anybody else? Or will I start asking difficult questions? I suppose the general one, I keep coming back to it because it's a problem I don't see the market looking at strongly, is how big batteries are going to be dealt with. That is a really big problem. I know we're joined by colleagues from Epiroc and Sandvik here today, is that, you know, battery swapping is the one obvious solution, but if you're keeping that thing on board, how are you going to DC fast charge a 200, 300, 400, 500 kilowatt hour battery? And what are you going to do with the heat off of that solution, off of that system? That's going to be, at some point, someone has to deal with this problem. And maybe even I know you're not on the thermal side, but on the Webasto side, Do you have applications where you are rolling out multiple of the thermal product in parallel to deal with very large scale systems?
So yeah, you mentioned, so I'm not from thermal side. Of course, we're experimenting as well. So how to deal with it? We have this pilot with this overall holistic integrated system. So there we can serve as well bigger solutions. Of course, with the EBTM, this would not be possible. Then we would need several of it, which is possible as well, but then maybe it's not that efficient. So yes, we're working on it, and there I see some opportunities, but it's special for our company since we have the expertise of heating and cooling the colleagues in-house, so they see opportunities, of course, but for me as a battery specialist, of course, it's a pain, same as you mentioned. For the overall company, there could be opportunities, but still we want to be efficient, ecological, economically friendly, so we have the overall picture in mind.
And one point I'd add is that it's most people, when they think about thermal management, it's about, right, I can't charge below 0 degrees C, so I must heat up, and if I get too hot, I must shut down. But there are some positive benefits, as I think some people had mentioned, about heating up the battery. Any of you that drive a Tesla will know that if you put in a supercharger destination, it will precondition the battery to 35 degrees C or higher to decrease the internal resistance. So that's maybe one of the opportunities of thermal management, is to really pull that maximum amount of performance. It will be for probably only special applications, I would say. General purpose things like operating for 8 to 10 hours is a relatively easy application on a battery. But for ones that need extreme power discharge, or potentially in mining for extreme regenerative braking during a decline or something like that, battery preconditioning could be a very important aspect of thermal management, in my view anyway.
And nobody said it's easy, but then the challenge is really in a holistic system to bring the energy where you need it, the heat and the cold, and really to distribute in the overall system. But yeah, it's not easy, so a lot of intelligence, maybe software needed for that.
I would add to that as well that we're only a component in overall projects. The greatest difficulty we see in virtually all new electrification projects is thermal systems. It's thermal system integration is what slows down every single project that we see. It's just completely underestimated at what has to be done and how to integrate everything together. Even things as simple as component availability. It's a huge problem. Those of you who are about to electrify, watch out for thermal systems, or ring this guy, or get Lena's contacts in the thermal group. Any other questions on the remote side, or maybe just a contribution?
No question, but when you're talking about charging big batteries with high power charger, and then especially on board, means that you need the power instantly. So you are a load on the grid with 350 kilowatts, for example, and why not thinking about, like Mr. Krummacher said, thinking about a second life battery, which is a kind of mobile storage, and use it as a kind of electrical toilet flush. So charge the battery, the mobile battery, slowly, and then when the machine comes, charge it with high power to bring it back doing its job. So to me, from an infrastructure perspective, that is by far the best solution compared to generate small, big loads which are only punctual linked to the grid.
One point I'd add is that obviously the DC fast charge levels 150, 250, 350, that's with automotive in mind. The big one that scares me from a thermal perspective is when the trucks come along. So obviously watching what the Tesla Semi and whatever they finally decide, I think it's 1,000 kilowatt hours is what's in it at the moment. But even if you look at the new standards that are being developed, the CHAR-IN initiative, they're talking about that standard at 3,000 amps at 1,500 volts. So that is going to be a lot of heat in a pack that big. And how are they going to deal with that is a big question. That's like 6 megawatts of charging capacity coming into a battery system, a mobile battery system.
So, and think about the efficiency of an HF charger, which is about 95, 96, 97% maybe, but it is still 3% loss, which is only heat. And when you have an onboard charger of that size, everybody knows that 2 kilowatt heater, what's tremendous heat it is, yeah? So when you have it on board, you have to get rid of it.
Yeah, no, I am for sure you're not going to have that level of power on board, but even the question of the power might be coming from off board, but I firmly believe you're going to see some sort of CCS 3 or 2 or 0.5 for charring, and possibly some other plug that's off-board cooling. You'll probably have likely a plate heat exchanger inside the vehicle, some high flow open loop flush on the system to deal with that power. And these are things that will be relevant to everyone in the off-highway vehicle segment, because your batteries are all going to be big. All the expertise, all of the components, all of the supply chain are building for batteries that are at most 110 kilowatt hours in the biggest premium sedans. Generally speaking, 60, 70 kilowatt hours. That's largely what, both of those thermal systems, 6, 7 kilowatts, that'll do it. 600 kilowatt hours, fast charging.
And even if that plug is liquid cooled, at that power, it has a tremendous size. It has to be manageable from a human. See, today's CCS2 is quite small, but even the cable is, I don't know what the cross section, but imagine you had 3 times the power you have to transmit. The cable is getting bigger, and you have to manage it. Or you have to think about pantographs or inductive charges.
Yeah, okay. Since I'm from Epiroc and
great.
OEM and user, and that was why one of the reasons why we were actually, okay, maybe I should do it like this. We were trying to and focus on swapping the batteries to reduce the pressure on the grid, to reduce the temperature requirements, to extend the life of the batteries. So there are so many benefits. And inductive charging, because in the mine, when you have a 40, 50 degrees ambient temperature, and you have a mud, and you have a whatnot on the floor and on the bottom of the machine, how efficient inductive charging would be. So that's why we're thinking, okay, the most easiest, and also the traffic conjunctions at the charging stations, and at the end of the day, the size of the grid. Because if you have 20, 30, 40 machines of the big size, our sub-pack is 93 to 120 kilowatt, times 4 or 5 sub-packs in one pack, you have a lot of kilowatts there. And you have dozens of machines waiting in the queue to be charged. I mean, imagine the size of the grid and the temperature that is emitted. So that's why we said, okay, it's better maybe to go for swapping and take it slowly at 2-3 hours, because you can run your battery for 5 hours. It's, again, question of management, of energy management, literally speaking.
The one point I'd put back to you is that, because we see it in requirements, it's often missed. It's what we call stealth fast charging, is the regen requirement. That's always forgotten. And mining is a fantastic application for that, because it's sustained regen. In automotive, it's 10 seconds, 8 seconds. In mining, it's 10 minutes, 20 minutes or longer. So it's one thing to consider the DC fast charger there, but if you want your 0.5C, 0.8C of a regen on a decline for 15, 20 minutes, you have the same thermal problem, except it's completely on board now. So do you have any comments on solutions around that?
No, not me, maybe my colleague who's more competent than me, but I don't. It is a complex. We do have we are handling that issue, but how are we handling, I don't know, to be honest. Anders, any addition? Okay.
Opportunity.
Yes, exactly.
So I guess that is something for me.
Yeah, for sure, yeah. And then probably Juho, because it sounds like it's up in the forest somewhere.
Yeah, to me, that is one of the biggest challenges. And that is challenge, not a problem. Because, 100 years ago, we had the challenge to get the gasoline only in a pharmacy. But we managed it to build up gas stations. So that is our today's challenge, how to get the infrastructure ready to supply charging possibilities to remote places. So either you have to invest in infrastructure, in cables, which is quite difficult, I guess, in the forestry industry and agricultural industry at all. The possibility I see today is working with mobile energy storages, charge them at one place, move them to the remote place, and then use it as a kind of battery pack, like with power tools, just in a much bigger dimension.
Yeah, we've seen that actually. There's a number of projects ongoing, particularly in the Scandinavian countries now, for site power, especially in Norway. That's what they're doing. The construction sites won't have any fuel, so the containerized power is coming in with CCS2 fast chargers on the side of it, also slow chargers, and the containers are swapped then, and that's how they're dealing with mobile site power. Substantially more difficult to go up somewhere that might have no roads or anything else. So maybe actually in that context, how do you get diesel up there?
Well, the diesel logistics is also challenging, but usually they can be managed. There are some kind of roads, or sometimes we need to build the roads for the trucks so they can get in the diesel. But it's already a challenge now. So then when we would be delivering, let's say, stationary energy storages to the forest, it would be a different challenge, maybe even a worse challenge, but somehow we have to manage that. I don't know if it's a stationary storage or spare batteries that we swap to the machines, or what that will be, but we just need to find the solutions. We cannot do it alone. We need good partners and for that, but I believe we can still find some kind of solution for that.
And would you feel that for your market that it definitely must move to battery in the future, or maybe a philosophy from Deere of, clean fuels? Like, it sounds like this is a very hard application to electrify.
Yeah, I would believe that the first step, like with many other work machines, will be some kind of a hybrid solution. It can be for many years, for a decade, and then at some point we will start experimenting with full electric systems, but it will take time, for sure. Yeah, hydrogen is one possibility. Yeah. But that's
swapping one problem for another.
Yeah.
Anyone else? Question? Time? Great. We have to all get a different type of liquid cooling now, I believe. So there's bottomless wine and beer, I believe now, right? And maybe the chairman will close the session.
So by that, we'll say a good thank you to the panelists for the session with a big applaud.
Thank you.
And I would also like to thank you, all the speakers of today, but also all of you in the audience, both here in the room and on the digital platform, for the interaction and the questions coming up and so on. And we have heard interesting discussions and presentation about everything from cell level to the surrounding system, the dependencies, you have the whole package, but also not only how to produce the energy, also that zero emission is very much about reducing energy in different ways. And it's all combined. And we've seen also alternative roadmaps. And given all these different aspects, and also I think was very much presented by the panelists here, that there is actually not one off-the-shelf solution for all kind of applications and conditions. So there are a number of options, and it has to be a number of options. And it's good to see that there are already now a number of available solutions for the future, and there's more to come. So I don't fear that we'll be lacking the need of engineering hours in the years to come. And so, but I think a good start of these engineering hours and in the innovation part is that next session of our conference here that we'll all meet just in a couple of minutes in the reception. It's called the open drinks reception. It's where we actually had the lunchtime. So feel free and continue the good discussions, and then we resume here tomorrow morning according to the agenda. Thank you very much for today.